Good afternoon. Good afternoon.
Good afternoon, sir.
Shall we start?
Yes, sir.
Sorry, in the previous class, uh, in this case, theta is in clockwise direction. Theta is in sorry. This theta is in clockwise direction. Therefore, this should be negative. This should be negative. Okay, I will correct it later. For time being, you understand that since theta is in clockwise direction, this sign convention has to be negative. Theta is negative here, and this is correct. And also, this is theta is in counterclockwise direction. This has to be positive. See, this clockwise. In the hurry, I did as in the last moment. So this has to be. This is negative. This is positive. Okay, we'll discuss sign convention later. Okay. When we come to the merge circle, we discuss sign convention. Also, when we come across analytical method, we have to talk about sign convention. Now, we will derive the expression for normal and tangential stress, principal stress, maximum shear stress for a body subjected to biaxial stress condition. Biaxial, as the name indicates, biaxial. On the two axes, the stresses are induced. There are no stresses. The stresses are induced along two axes. This is nothing but biaxial. If we consider a body along two axes, there are stresses induced sigma x, sigma x, sigma y, and sigma y. There are no shear stresses. Only along two axes, stresses are induced. Okay. Derive an expression for normal and tangential stresses for a body subjected to biaxial stress condition can be asked for 8 marks. Okay. As usual, I'll take an element. Like this. This is my plane. I will call it as this. I will call it as A, B, C, D, E. Okay. I will take the element. I will take the element BCE. This is my BCE. B, C, E. You can see there is sigma x acting like this, sigma y acting like this. For equilibrium, for equilibrium, when I take a section like this, this is the plane at certain angle. When I measure the anti-clockwise direction, this is theta positive. For equilibrium, there should be a normal stress sigma n acting like this, and also a tangential stress. Sorry, and also a tangential stress zig, a tangential stress parallel to the plane sigma t acting like this. Okay, that you should understand. For equilibrium, there should be a normal stress sigma n and tangential stress sigma t. This axis is nothing but your, this is called as normal. Don't worry, this is your n axis, this is your t axis. Normal axis, normal to this plane B, and tangential to this plane B. Okay, now I have this sigma x and sigma y and sigma n and sigma t. I will represent this in terms of forces. It's because it will lead to complication while solving. I'll just represent in terms of forces, because when I'm taking, I will always talk about summation of forces is equal to 0. Okay, when I talk about summation of forces is equal to 0, this is not summation of stresses is equal to 0. Summation of forces is equal to 0. So, but there is equilibrium equation dou sigma by dou x plus dou tau x by dou y plus dou tau x by dou z plus body force, like 3 equilibrium equations are there. But it is for three dimensional body. But in this case, we are talking about a summation of forces is equal to 0. For any body, if it takes talk about equilibrium, summation of forces in three mutually perpendicular directions has to be 0, and summation of moment should be equal to 0 for static problem. Whereas for dynamic problem, body should move with a constant velocity, including this equilibrium condition. Summation of forces and moment should be equal to 0. Okay, keeping this in mind, I will write this B, C, E. I'll represent sigma x instead of sigma x. I will write it as f of x and f of y. Normal force f of n, tangential force f of t along this parallel this plane B. Okay, let me write I'll write it as f of x is equal to sigma is equal to p by a, or sigma into side BC into 1, sigma x into BC into 1. Similarly, f of y, which is equal to sigma y into CE, sigma y into C into 1. Thickness is 1. Area I'm taking, area is BC into 1, C into 1. F of n, which is equal to f of n sigma n into B into 1, f of t, I will write it here, f of t, which is equal to sigma t into BE into 1. Which is nothing but sigma x into BC, sigma y into CE, sigma n into BE. F of t is equal to sigma t into BE. Okay. Now, uh, I want to resolve the forces. I will take one by one force. First, I will take, let me write dex. You can resolve here only, but in order, there are two forces, f of x and the f of x and f of y. I want to resolve f of x first in x along normal and tangential direction. First, I will take x and y. This is my normal. This is my normal. This is my tangential. Along normal, f of n acts, along tangential, f of t acts. Okay, let it be. Okay, now now f is acting like this. F of x is acting like this. F of x is acting. I will draw t. I will draw a line parallel to t here. That is, it is perpendicular to your f. This is like this. Okay. Now this is the f of x is the resultant. Then this is theta. This is also equal to theta. Then the resultant force. If this is theta, forget about the f of n. Okay. If I'm resolving this f of x, this would be fx cos theta. This would be fx sin theta. Right. Next, I will take the force f of y. Force f of y. This is how you have to resolve in the examination also. Technically, you should do. It is very simple if you follow the steps. I'll take the normal axis. I'll take the tangential axis. Okay. I'll take the tangential axis. Okay. This is also at an angle theta. This is also at an angle theta. Now I have resolved f of x. I want to resolve f of y. I want to resolve f of y. F of y. f of y. This is f of y acting downwards along y-axis. I will draw a line parallel to normal axis. This is n. This is f of y. This is theta. If this is the resultant, this arrow will follow like this. This arrow will follow like this. This is f of y sine theta. This is f of y cos theta. Right? We have result of first your 50% job is over when you write this. So when I take sigma x, sigma y, there is sigma and sigma t. This is f of n, f of t. Can I write? Summation of force in normal direction should be equal to 0, or f of n is the force acting like this. F of n in this is f of x is acting opposite to f of n, opposite to the normal axis. Hence, f of n minus f of x cos theta, f of x cos theta, and also this is acting opposite to my normal axis. Normal is like this, opposite to my normal axis. That is opposite, similar to negative y axis, negative x axis. Minus f of y sin theta is equal to 0. Summation of tangential force should be equal to 0. Let me write f of t is positive, acting upwards like this, f of t plus here f of x sin theta, and here minus f of y cos theta is equal to 0. If you write this, your 50% your job is over. Then it is just substitution and solving the equation. Okay. Now I will solve this. Give me a moment. Okay. Now let me write the equations. Summation of f of n is equal to 0, which is equal to f of n minus f of x cos theta minus f of y sin theta is equal to 0. Okay, or f of n, which is equal to f of x cos theta plus f of y sin theta. F of n is nothing but f of x cos theta. F of n is nothing but sigma n b, sigma n b is equal to f of x sigma x bc, sigma x bc cos theta plus f of y sigma y c, sigma y c sin theta. Or if I take true, divide throughout by b, sigma n, which is equal to sigma x bc by b cos theta plus sigma y c by b sin theta. Sigma n is equal to sigma x bc by b, bc by b is adjacent, which is equal to cos square theta plus sigma y ce by b, ce by b is sin theta, sigma y sin square theta. Right? Next, we need to derive expression for f of t. Okay, this can also be simplified further. Cos square theta sigma n, which is equal to sigma s. Cos square theta is equal to half into 1 plus cos 2 theta plus sigma y sin square theta half into 1 minus cos 2 theta, or sigma n, which is equal to sigma x plus sigma y by 2 plus sigma x by 2 cos 2 theta minus sigma y by 2 cos 2 theta, or sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. This I will call it as 1. Next, summation of tangential force is equal to 0. The equation is f of t plus f of sin theta minus f of a cos theta. Okay, f of t plus f of x sin theta minus f of y cos theta is equal to 0. 0. Or f of t is equal to minus f of x sin theta plus f of y cos theta. f of t is equal to sigma t into b, sigma t into b, which is equal to minus f of x is sigma x into bc, sigma x into bc sin theta, plus f of y sigma y ce, sigma y ce, sigma y ce, ce cos theta, right? Next, dividing throughout by b, sigma t minus sigma x bc by be sin theta plus sigma y ce by be cos theta. Or I can write written here, copy that, sigma t is equal to minus sigma x bc by b sin theta, sigma x bc by b sin theta plus sigma y c by b cos theta, sigma y c by b cos theta, sigma t is equal to minus sigma x bc by b, bc by b is cos theta sin theta plus sigma y ce by b, ce by b sin theta cos theta sin 2a is 2 sin a cos a minus sigma x sin 2 theta by 2 plus sigma y sin 2 theta by 2. Okay, sigma t minus half sigma x minus sigma y by 2 sin 2 theta, minus of minus into minus sigma x plus sigma y is one and the same. Okay, I can write like this. Sigma n I got, sigma t I got. This is the normal and tangential stress acting on this plane. Okay, any body if I take, I want the stress acting perpendicular to the surface. There is the normal stress, and parallel to the surface there is a tangential stress, also called as shear stress. I got sigma n and the sigma t, sigma n and sigma t. Okay, there is nothing but tau and sigma. Now I want to obtain the expression for principal stress for this stress complex. Principal stress is for this. So if you take a body, and if this is a point I'm talking about, there are infinite number of planes you can pass at this point, but the principal stress remains the same. At this point, the principal stress remains the same. Any number of planes we can pass, state of stress changes, but the principal stress sigma 1, sigma 2, sigma 3 will remain the same. It depends upon whatever it is given for this plane, right? Sigma x and sigma y. Principal stress at this point remains the same. We need to calculate the principal stress for this. Even if you take this plane at this point, principal stress remains the same. Okay, because principal stress is an invariant. Okay, it will not change if you change the coordinate system. Okay, now keeping that in mind, I have found sigma n and sigma t. I want to find the principal stresses. Let me give it in procedure to find principal stresses, different principal planes and stresses. Sigma normal is given as sigma normal, which is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. This is sigma normal. Okay. Now to find the principal stresses, as in the previous case, I did it but just by inspection. That that my this cos theta is equal to 0, then my sigma is equal to sigma x, then that can be the maximum value. But in this case, I cannot just say it by inspection. What we know from the basic mathematics, if I differentiate if I differentiate this and equate it to 0, okay, if I differentiate twice, if this value is negative, then it is called as maxima. If the value is positive, then it's minima. I will not go up to second derivative. As we know, we will derive it first and we can equate it into 0. Okay, dou sigma n by dou theta, which is equal to 0, which is equal to sigma x minus sigma y by 2 cos 2 theta, which is equal to minus 2 sin 2 theta, or sigma x minus sigma y minus sigma x minus sigma x minus sigma y sin 2 theta is equal to 0. Okay, this will be equal to 0. This will be equal to 0 one for 2 theta is equal to, for what values? So sin will be 0 for what values? 2 theta is equal to 0, isn't it? 2 theta is equal to 0, or 2 theta sine of 180 is also equal to 0. 2 theta is equal to 180. Okay, 2 theta is equal to this. Don't worry. For theta, then 2, for example, for it, when the first value will take 2 theta is equal to 0, therefore theta is equal to 0. This we'll call it as theta 1. Okay, the first principal stress and the second principal stress are 90 degree to each other. Theta 2 is equal to theta 1 plus 90, or theta 2 is equal to 0 plus 90. Theta 2 is equal to 90. You can substitute in this sin 2 theta. So in case of theta, you can substitute for example, in case of theta, if you substitute theta 1 is equal to 0, this entire term will be 0. Then sigma 1 will come maximum. We'll discuss that. And theta 2 is equal to 0, sin 180 is 0. Okay, now we got the planes on which the principal planes, these are the principal planes. Principal planes exist at theta 1 is equal to 0 and theta 2 is equal to 90 degree. Now we need to find the magnitude of, of principal stresses by substituting theta is, you can write theta 1 p or theta 1, let me write just theta 1 p and theta 2 p in sigma n. I'll call this as theta 1 p, theta 2 p. Okay, this is 2 theta. If you call this a 2 theta p, this is theta 1 p. Don't worry about p and all. This is principal planes, principal stresses. That's it. So if I substitute 2 theta equal to 0, then this will be equal to 0, I got the planes on which the principal stresses are maximum. There is on theta 1 is equal to theta 1p and theta 2p. Theta 1p is equal to 0. Theta 2p is equal to 90 degree. Substitute these values in sigma n. Sigma n is given by, to find the magnitude of principal stresses, sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 sine 2 theta. For theta 1p is equal to 0, sigma 1 which is equal to, if I substitute sine 0, sigma 1 will be equal to sigma x plus sigma y by 2. For theta 2p is equal to 90 degree, sigma 2 is equal to sine 90 degree, sine 180 is also 0, which is also equal to sigma x, which is also equal to sigma x plus sigma y by 2. So these are the magnitudes of principal stresses. Sigma 1 is equal to sigma x plus y by 2. Have I done any mistake? Theta 1, sigma 1 sine 0. Which expression I have taken? Give me a moment. Is it cos theta or sin theta? Sigma. Sorry, this is cos theta. Okay. Cos 2 theta. Sigma x plus sigma y by 2. Cos 0 is 1 plus sigma x minus sigma y by 2, which is equal to sigma x. This is cos cos 90 degree, right? Cos 2 into 90, cos 180 is minus 1, minus of sigma x by 2 plus sigma y by 2, which is equal to sigma y. Therefore, sigma 1 is equal to sigma x. The second principal sigma 2 is equal to sigma y. Okay. So this planes itself, sigma 1 is equal to sigma x is the first principal stress. Sigma 2 is equal to sigma y is the second principal stress. It is directly inference from this, isn't it? There are no shear stress acting on this plane. Therefore, these planes itself has to be the principal stress. There is an inference from this. Okay. Sigma 1, this normal, this is the plane, and this is the plane 90 degree to it. These are itself are the principal stresses. Okay. Now we can cross check. Whether there is any shear stress, to cross check, to verify whether shear, this is not required, but I am doing shear stress acts on at the principal planes. Sigma t is given by this sigma t is given by, give me a moment, which is equal to minus sigma x minus sigma y by 2 sine 2 theta. These are the principal stresses, theta 1p, theta p, theta 2p, or theta 1p if is equal to 0. Therefore, sigma t is equal to 0. If you substitute 2 theta is equal to 0, this is 0. At theta 2p is equal to 90 degree. Therefore, sigma t is equal to sine 180 is also 0. Therefore, there is no shear stress at tau acting on the principal planes. Hope you can understand. Okay. Now we will represent the principal planes, how the principal planes are. Okay. First, in order to represent that, we need to, I'm left with 10 minutes. I'll schedule one more link, another 10, 15 minutes I may require. I'll send you one more link. As soon as I send you the link, please log in. Okay. Now let us take XY coordinate system. You can see here, theta 1p is at 0 degree and theta 2p is at 90 degree. You can represent that. This is principal plane 1, which is at an angle 0 degree, principal plane 2, which is at an angle 90 degree, and you can write, as soon as you write the principal plane is acting perpendicular to the surface. There is a plane, you represent like this, and you should indicate the magnitude, and the magnitude is equal to, you can write directly sigma 1 is equal to sigma x, sigma 2 you can write directly like this, sigma 1 is equal to sigma x, this phase sigma 1 is equal to sigma x, sigma 2 acting perpendicular is equal to sigma y, sigma 2 is equal to sigma y, right? Any doubts here up to here? Any doubts you have? This is about the principal stresses we have done. Next we'll talk about shear stress. On the 8 minutes remaining, we'll talk about shear stresses. Shear stresses, what is the equation we got? Huh? 2 to determine the planes of maximum shear stress and its magnitude. For that, I want to take sigma t expression, which is equal to sigma t, which is equal to minus sigma x minus sigma y by 2 sin 2 theta, minus sigma x minus sigma y by 2 sin 2 theta. But just by inspection, I can say sigma t is maximum for 2 theta is equal to 90 degree. Or I will like 2 theta, this is tangential shear stress rate, I will represent it by S, principal stress I will represent it by P. 2 theta is equal to 90 degree, or theta S1 which is equal to 45 degree. Theta S2 which is equal to, they are 90 degree apart, theta S1 plus 90 degree, therefore theta S2 is equal to 135 degree. Now I want to determine the sign or direction, to determine the direction of tau max or sigma t max. Okay, you will get confused. First, let me solve in the sequence. Now I have obtained this to find the magnitude of maximum shear stress. Substitute theta S1 to find the magnitude of magnitude shear stress, to find substitute theta S1 or theta S2 in sigma t. Tau max, tau is complementary. If one is positive, other will be negative. Okay. Give a moment. What we obtained? Sigma t, theta S1 45, theta S2 135. I need to find the magnitude. Sigma t, which is equal to minus sigma x minus sigma y by 2 sin 2 theta for theta S1 is equal to 45 degree, sigma t max, this is maximum. These are the planes on which shear stress are maximum. There is theta S1 equal to 45 degree, sin 45, sin 2 theta, sin 45 will be 2 theta into 45 into 2 will be 90. This will be equal to minus of sigma x minus sigma y by 2. For theta S2 which is equal to 135 degree, sigma t max, can you tell me what is this value? Minus of sigma x minus sigma y by 2 into sin 270. What is sine 270? Check it out. What is sine 270? What is sine 270? Is it positive sigma x minus this minus 1? Is it minus 1? What is sine 270? What is sine 270?
-1, sir.
Minus 1, right? So this sigma t max, sigma t or tau max, I can write tau max or tau min or sigma t max. Give me a moment. Or sigma t max or sigma t min, which is given by plus or minus sigma x minus sigma y by 2. Okay. Now you take a break. Next, in a moment, I will be sending you the second link. Another 10 minutes only I will take. I will represent the planes, shear strength at 45 degree and 35 degree, and you need to find the average stresses. Okay, because on the shear stress plane, as you've seen here, there is no tangential stress on the principal plane, but there can be, this one. But there in the shear stresses on this plane, there can be average stress. There is an normal stress acting. We need to obtain the value magnitude of those average stress, and then we'll represent and we'll wind up the class. Okay, I will send you the link. Kindly log in. It takes another 2-3 minutes. I'll be sending it.